we're going to start putting everything together now. So you'll notice up here we've got the quadratic relation is y is equal to a times, in brackets, x minus h all squared plus k. This is actually probably one of the most important equations that you're going to learn all year. And this is known as the vertex form of a quadratic equation. And the reason why we call it the vertex form, okay, is because the vertex is always found by the hk values. Okay? So the fact that we know what the vertex, that we can visually see the vertex on this parabola, allows us to identify what two of the three unknown coordinates are. Okay, we can figure out h and k from just looking at this graph. Okay, so in this particular instance, when we look at this graph, we got to identify where the vertex is, and the vertex is where the graph changes direction, and that happens to occur right up here. Okay, and so that vertex is actually at -1, +3. Okay. Now I told you that the vertex form of the quadratic equation is the same as the hk value. Okay, that means that the h value is -1, and the k value is +3. Okay. Now because this particular parabola opens downward, that means that it's going to actually have a maximum value. Okay, and its maximum value is going to be the k value. So the maximum value happens at k, and so the maximum value is actually +3. So if you look at this parabola, there are no points on this parabola that are higher than +3. So there is no minimum value for this particular parabola. Okay, so we can cross out the minimum value. This parabola does have something called an axis of symmetry. In fact, all parabolas have something called an axis of symmetry. We'll talk about this piece a little bit more later on, but the axis of symmetry is basically the line that divides the parabola in half. Okay, and we call it an equation of an axis of symmetry. And the reason why the axis of symmetry is so important is that it actually goes right through the vertex. Okay, and so there is an invisible line that goes through the vertex. Okay, and the axis of symmetry, or what I call the AOS, just for short form, is always equal to the h value. Okay, so we know that the h value from the vertex is -1. That means that the axis of symmetry, or the AOS, happens when x is equal to -1. So when I ask you for the equation of the axis of symmetry, your correct response would be x equals -1. Or always when x is equal to the h value. You have to substitute in what the actual h value is. Okay. In this particular equation, or graph rather, it does have a y-intercept, and we can see that happening right here. And so the y-intercept happens at +1. It does also have a pair of x-intercepts, although they're not as clear-cut. One happens somewhere between -2 and -3, and another happens between 0 and -1. So for simplicity's sake, I'm just going to make up a number in this particular instance. So it'll be, we'll call it -2.3 and 0.1. Okay, and again, the x-intercepts happen because the parabola crosses the x-axis. So when y is equal to 0, there are two values of x. And in this instance, what we end up seeing is that it happens twice. And so because it happens twice, we have to use the word and, not or. Okay? So there are two of them, not one or the other. Okay? So again, looking at this particular graph, and based on the vertex and some of the other pieces of information, we can fill in other components. So we know what the h value is. The h value is -1. We know what the k value is. It's +3. Okay. Now, if we look at this particular graph, we can actually figure out the step pattern, which will give us the a value. Okay. So remember, the step pattern normally works by uh, by figuring out x, y1, y2. Okay? And so in this instance, our normal step pattern goes 1, 4, 9. But in this instance, because we can see this parabola, we can actually visually inspect what that step pattern is going to be. So from the vertex of negative 1, 3, we can go over 1 unit and then down however many units until it actually crosses the next point. So we go actually down 2 units. So it's actually y2 is negative 2. If we continue on, we could potentially figure out what uh, the next step in the pattern is going to be. So if we go over 2 units from the vertex and we go down 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it would be negative 8 units down. Okay, so based on this, we can kind of reverse engineer our A value. Okay, so if we take our y2 value and we divide it by y1, we can figure out A. Okay, so A is equal to y2 divided by y1. Okay, and so y2 is negative 2, y1 is 2, so that would equal negative 2. The other one, negative 8 divided by 4 is equal to negative 2. So in this instance, we can use our step pattern to actually identify that the A value is actually negative 2. And because we know what the step pattern is, we can use all that information together, okay, to actually come up with the equation. Because we now have an A, H, and K value. So remember, the equation of a parabola is always in the form, or in vertex form, is y is equal to a x minus h squared plus k. So now we're just going to substitute in the values that we have. So if we substitute in our values, we end up with y is equal to negative 2 x minus h, so minus negative 1 all squared, and then k is plus 3. Okay, so we can simplify this piece in the middle here. So let's do that. So we end up with y is equal to negative 2x. So negative 1 times negative 1 is actually plus 1. Okay, squared plus 3. So our equation for this particular parabola is given to us right there. Okay, so by looking at the parabola, identifying the vertex, and then figuring out the HK values, and looking for the y-intercept and the axis of symmetry and so forth, we can actually derive the equation of a line, or of a parabola.